Hi class. So we'll look at the last section of the unit, which is looking at equations and graphs of polynomial functions. So first off, we'll get into some terminology. When a function basically goes to the x-axis, there's a couple of different things that can happen. One is the function can turn around. Okay, so that's what's happening in this first illustration here. Okay, so this is what we mean by the function turning around. What's happening is it's going this way and then it goes up like that, or vice versa. So this occurs when our k value, and I'll get to what the k value is a 0. Okay, so like in this case here, fx equals x minus 3 squared. The k would be the 3. Okay, so it's what causes it to become a 0. So when the k's is a 0 of even multiplicity. Okay, so when we talk about multiplicity, what we're referring to is the exponent. So you see how the exponent here is 2, right? So that's what we call the multiplicity 2, and that would be even. So when you have even multiplicity and the 3 here is your k value, right? So that would be the k value right there. Then what happens is the function turns around. Okay, if k is a 0 of odd multiplicity, then what happens is the function just basically passes through the x-axis in the same direction. Okay, so here's where it's essentially just crossing. Okay, so it maintains the same direction it was going. So here again, k would be would be 3, and the multiplicity here is odd because it's a cube function. Okay, so it's just more information that we can gather from the function. So let's I'll show you how you can kind of implement that. Okay, so let's look at this function over here. So before I do anything, just by looking at the picture, what I can gather is this would have to be odd multiplicity because it just passes through. This one here would be even because it changes direction, and then this one here would be odd. Okay, so again, the multiplicity refers to the exponent. Now, the least possible degree, I'll come back to that. Okay, so let's look at the sign of the leading coefficient. So what we see here is this function is basically extends upward in quadrant 1 and quadrant 2. Okay, so if you think about that, okay, so here's 1 and here's 2. Okay, so if you think about what else does something like that, would be like a positive parabola, right? A positive parabola would extend upwards in quadrant 1 and quadrant 2. So the sign of the leading coefficient then, in comparison to like a parabola, this would have to be positive. Okay, the x-intercepts of the factors of the least possible degree. So what that is saying is in terms of where it's crossing. So where we're crossing here is at -3, at 2, and at 5. Right? So these would be your x-intercepts. So now the way we can present that, so connect this back to the odd even multiplicity, and what we do is we kind of look at the least possible degree. So it doesn't mean that this is what it has to be, but this is what the least possible degree that would satisfy that. So for -3, that corresponds to x plus 3. Okay, so remember how the sign is opposite. Okay, for and so notice how I don't have an exponent on that, okay, because an exponent of 1 would be odd multiplicity. 2 would be x minus 2, and then I'm going to put squared. Okay, so why am I putting the square there is because I know the multiplicity has to be even, and the least possible one it could have would be squared, right? The next one would be like a power of 4. Okay, and so again, x plus 3, I put a 1 there because that's the least possible one. The next one would be like a cube. Okay, and then we've got 5, which will be x minus 5. And again, this is the power of 1. Okay, so if you look at what we've got here, we've got a power of 1, power of 2, and a power of 1. So altogether, what does that give you? That gives you a power of 4. So the least possible degree, to come back to A, is going to be 4 because of 1, 2, 1. That works out to the 4th power. Okay. And then the intervals where the function is positive and where it's negative. So positive, what we mean is above the x-axis, and negative is below the x-axis. So this is going to be positive for x less than negative 3 and x less than, x greater than 5. Okay, it's going to be negative okay, so negative for x between negative 3 and 2, and it's going to be negative between 2 and 5. So that's information that we can extract from the picture of the function. Now the other thing we can do is we can take the graph that we take the equation, and we can sort of come up with the graph from that. Okay, so without using a graphing calculator or without using a program like Desmos. Okay, so what we have here is this equation written out in factored form. Okay, and what we got here is we've got a cube, right? So we've got a 3. And this one's the power of 1. So if you put these two together, what you have here is a degree equal to 4. Okay, so a cube and a 1 gives you a degree of 4. The leading coefficient here is going to be positive 1. Okay, so it's positive 1. Okay, from here you've got your x-intercepts. Okay, x-intercept is going to equal 2 and negative 1. Okay, your y-intercept. Okay, so how do you get your y-intercept? So sub in x equals 0. Okay, so if you sub in x equals 0, so you're going to have 0 minus 2 cubed and 0 plus 1. So that's just going to equal negative 2 cubed, which is going to equal negative 8. Okay, so right now we can put some key points here. So we've got 8 as the y-intercept. Okay, we've got the x-intercept at 2 and negative 1. Okay, so with that information, now the other thing I can do is I can figure out where am I going to be positive and where am I going to be negative. So basically what you want to look at is your intercepts. Okay, so you want to look at the left of the intercept, in between the intercepts, and to the right of the intercept. Okay, so like for example, if we look at, let's say we look at -4, okay, which is to the left of the -1 intercept. Okay, so if we look at -4, that is, and you sub that into the equation, that's going to give you -6 cubed times -3. So that's going to work out to a positive. Okay, so what I did there was I just used a test point, and so I know that this function is positive when x is less than -1. Okay, let's use the point on the right. So the point on the right is at intercept of 2. So let's say we used 3, right? So you put 3 in. So 3 minus 2 is 1. 1 cubed is positive. 3 plus 1 is 4. That's positive. So two positives times each other is going to be positive. Okay, so that tells you you're also positive when x is greater than 2. Okay, so if you kind of see what I'm doing here, I'm just trying to accumulate information that will allow me to, oh, I made a mistake here. This intercept should be at -8. Okay, so the y-intercept, that is. So what I'm doing here is I'm trying to get information together, enough kind of information so that I can put together a rough sketch. Okay, again, I'm not using any technology to determine this. The next thing I can look at is between -1 and 2. So let's say we tried 0. So if I put 0 in, well, we saw what happened. The y-intercept was -8. So that means that's going to be negative, right? So negative is going to be between 2 and -1. Okay. Now, the other thing I can look at is, so both of the multiplicities here are odd. So what that tells you is there's not going to be any terms in the function. And then the cube one corresponds to the 2. And I'll show you how to kind of put that cube part in there. Okay. So let's draw this out now. So basically what I have is, again, we're just passing through. Okay, so this part is just passing through. And then now watch what happens when I get to 2. Okay, so if you see what happened at 2, that little squiggly curve there, that resembles what goes on with a cubic function. And so the reason why I did that is because the x minus 2 had a cube going with it. Okay, and so there's your function. So again, that's how you can graph without the use of technology, by just kind of all this information, getting all this information, then implementing it. Okay, let's look at another example here. Example for B. Now this one, you notice is not in the same form, and so this doesn't give you the information that you got from part A. So what you have to do is, and I've already showed you how to do this, you have to either use synthetic or sorry, before we get to that, what you have to do is you have to factor. Okay, so remember what we did is, the first thing we did is we look at the C term, the constant term 12. So you've got 1, 2, 3, 4, 6, and 12. So those are the factors. Remember, some of these can be positive or negative. So those are the factors of 12. And so remember, the first thing what we want to do here is we want to factor this whole function. Okay, so that's the first thing we want to do. But because it's a cubic function, or it contains a cube, it doesn't contain a square. It's too hard to factor. So this is where we kind of use that trial and error method, where we go through those and we determine which one's the factor. So because I've already done this, I'll just, I can go through these, and so the one I found that worked was f minus 3. And so the reason how I know this works is if you substitute this and you work that out, that equals 0. And so because that equals 0, that tells you that x plus 3 is a factor. Okay, so this is what we did in the prior topic. Okay, so now I know that's a factor, and so now what I do is the next thing I do is I use use long division or synthetic division. And what I want to do is I want to divide. So basically what I'm going to do is I'm going to take negative x cubed plus 13x plus 12. I'm going to take this whole thing and divide it by x plus 3. Okay, so using either synthetic division or long division. And so after I do that, what I'm going to get is what I'm going to get here is x plus 3 and negative x squared plus 3x plus 4. Okay, so what's happening is this negative x squared plus 3x plus 4, that's what I get after I do the division, and the x plus 3 was the factor I already determined. Okay, and so now after you do that, you factor this part. Okay, and so what this is going to work out to is negative x, it doesn't matter what order here, x plus 1, x plus 3, and x plus or x minus 4. Okay, so x plus 1 and negative x plus 1 and x minus 4 is what you get from factoring that. Okay, so basically, let's just go back to the top here. So this function then is equal to negative x plus 1, x plus 3, x minus 4. Okay, and so that's what we just determined. Okay, so now after you do that, now it's the same thing as before. Okay, so what we can do here, just from looking at that, I know you've got your x-intercepts at negative 1, okay, at negative 3, and at positive 4. Okay, and then your y-intercept. Your y-intercept, so if you sub in 0 for x, you're going to get 12. Like you can see that from the original function, right? So 12 is going to be your, I'll just put that up here. That's going to be up here. Okay. So this is at 12. Okay. And so now, if you look at your brackets, x plus 1, x plus 3, and x minus 4, they're all with, they all have odd multiplicities of 1, which means you just pass through each time you hit the x-axis. You've got a negative leading coefficient, okay, and so altogether this is cubic, and so if it's a cubic, it's following a cubic pattern. That means you're talking about going up quadrant 2 and going down quadrant 4. Okay, so you're essentially following y equals negative x. Okay, so remember at the beginning of the notes, the first unit, we looked at characteristics of polynomials, and we saw that that illustration with the different types of functions. Okay, and then you can use the test points to determine whether you're positive or negative, okay, relative to these x intercepts. Okay, so altogether then, doing the same thing we did in A, you're going to get a graph that kind of looks, and again, this is a rough sketch, right? I'm not using technology, so it's not going to be like 100% accurate. Okay, so there's your function. Okay, so it's important that you understand what we were talking about with multiplicity being odd or even. Okay. Okay, let's look at the last one. So here, just like all the other functions we've looked at, you can apply transformations. Okay, so a, b, h, and k are the same as what we talked about before. And so here, so what you want to do is you want to compare this to the base function. Okay, so again, without using technology, what you can see is this is cubic. Okay, so what you can do is you can just look at a regular y equals x cubed function, make a table of values. Okay, so I'll just use a few, and I'll show you. I'll just use 0, 1, -1, 2, and -2. Okay, so 0, 0, 1 is going to be 1, -1 is going to be -1, 2 cubed is going to be 8, and -2 cubed is going to be -8. Okay, so let's go through what we're doing with the transformations now. So remember, when we did this before, we're basically using our mapping technique. What we do first is we take care of stretches and reflections. Okay, and then we get to the shifting horizontal and vertical, right? The translation. Okay, so if you look at the x, you've got that 2 in front in brackets. So what that tells you is your x term you're going to divide by 2, and you've got that -4 in front of the whole thing, and that goes to the y. So the y we're going to multiply by -4. Okay, and so let's take care of the x's first. So divide everything by 2, so you get 0, 0.5, -0.5, 1, and -1. Okay, so that's your x's. And then the y we're going to multiply by -4, so you get 0, -4, +4, -32, and you get +32. Okay, so that takes care of your reflection and your stretch. And then the next thing we can do is work on the translation. And so x, we're going to go to the left 2, so we're going to take away 2. And the y, we're going down 5, so we're going to take away 5. Okay, so here you're going to get -2, -1.5. So we're doing the x first here. -2.5, -1, and -3. Okay, and then subtract by 5, so 0 minus 5, so that's going to be -5, -9, -1, -37, and 27. Okay, so we got that done. Now let's plot this. Now if you look at the last two here, I'm not going to be able to plot this on the grid, but this is useful information anyways, because basically what that tells me is this graph is super narrow. Okay, so let's do the other ones here. So we've got -2, -5. Now this point here, the 0, 0. So remember what a cubic function looks like. A cubic function is something like this. Okay, and then this little the middle part here, this is your 0, 0. Okay, so the reason why that's significant is that type of shape there is going to occur because this was your 0, 0 point here, which corresponds to the -2, -5. So that's why that's significant. So we know that's going to happen. That same type of shape is going to happen there. So -2. -2, -2, -5. Okay, and then you've got -1.5, and negative 9. Okay, and then you've got negative 2.5 and negative 1. Okay, and so, and then the other points, they're way, so remember we had negative 1, negative 37, so that's like way down there, and then the other one you had negative 3 and positive 27, so it's way up there. So again, what that just tells you is it's really narrow. Okay, so this is going to look something like this. Okay, so again, really, really narrow, and then there's that little curvy part in the middle there. Okay, which is like your 0, 0 after it's been shifted. Okay, so I'll stop there. So that's the final section of the polynomial function unit. Okay.